Hey mathematicians, here are your notes for 2.1. We're going to talk about modeling with linear functions. So I'm going to jump right into the exploration portion. It says a company purchases a copier for $12,000. The spreadsheet, right here, shows how the copier depreciates over an 8-year period. Write a linear function to represent the value v of the copier as a function of the number t of years. So the first thing we have to do is see what was the value at the very beginning. How much did this copier start out at? Well, we notice it started out at a value of $12,000. And then each year you'll notice it went down by the same amount. It decreased by about $1,250. So when we're writing our equation, we're going to say the value v of t, so value in terms of time, is equal to the 12,000 it started off as minus that $1,250 per year. And we say per in math using the multiplication sign, so $1,250 per year. So 1 year we went down by 1 times 1,250. At the second year we went down by twice that amount, and so on and so forth. So there is our function. Next up, it says sketch a graph of the function and then explain why this type of depreciation is called straight line depreciation. So I've already labeled my x and my y axes, and then of course I'm going to throw some numbers in here. So after 2 years, 4 years, 6, 8, 10, value in thousands, let's go up by the same amount, 2, 4, 6, 8, 10, 12. We know it started off at year 0 at $12,000. A few of these are kind of in between the marks, so I'm just going to do the easiest one I see next, which is at year 4, it was worth $7,000, so I'm going to put that. And of course, because it was going down by the same amount, we can draw that straight line because we know it was decreasing by the same amount each year. I'm going to grab my straight edge here. Bop, bop. And it said at year 8 it was at $2,000, so let's actually give ourselves another target there. There, three points is usually easier to line up. And then of course, my little arrow. So now let's talk about why this is called straight line depreciation. You'll notice that the copier is depreciating in value at the same rate each year, meaning this line doesn't wiggle at all. It's the same depreciation rate. So that would be why it's called straight line. The rate of depreciation does not change, does not vary over time. It is the same each year. So I know this last one is hard to see, but it says interpret the slope of the graph in the context of the problem. So if we know that we're going down, we're decreasing by 1,250, in terms of the problem, that just means it's losing that much value per year. So each year, the copier decreases in value by that $1,250. All right, let's keep going with this. This one says match each description of the situation with its corresponding graph. So a person gives $20 per week to a friend to repay a $200 loan. Second one says an employee receives $12.50 per hour plus $2 for each unit produced per hour. A sales representative receives $30 per day for food plus 56.565 cents for each mile driven, and a computer that was purchased for $750 depreciates $100 per year. So the first thing I noticed about these graphs is I have 2 appreciation and 2 depreciation. So we've got 2 increasing and 2 decreasing. So I can already kind of start to match my situations with whether or not money is increasing or decreasing. The next easiest thing would be to say these all have a starting value, so I should know at time 0 for all of these graphs the starting value. So let's go ahead and just start matching them up. A person gives $20 per week to repay a $200 loan. Because the $20 is per week, that's a rate, meaning that our $200 is going to be our starting value. I notice there's only one of these graphs that starts at 200. It does look like it's going down, so that could be A. So I'm going to say that's possibly A. I also notice that it eventually gets to 0. If we're repaying a loan, we want to end up back at 0. So that would make sense. However, let's keep looking here. An employee receives $12.50 per hour plus $2 for each unit produced. Well, that's going to be an appreciation, meaning we're going to start at about $12.50 and go up. Notice none of these are even in that range. This is the only one that starts anywhere close to that. So this one has to match up. So this is definitely graph C. And it's, if you want to put the explanation, it would be the graph starts at $12.50. Notice for the last one, I couldn't say it right away. I have to look into it a little bit more. But for this one, because it's the only one that starts at $12.50, we're good to go. A sales representative receives $30 per day. Again, none of them even start close, so that one's going to be A. At this point, I've kind of broken down my graphs a little bit, so I'm going to say that this goes with A. So I have to bring B up here. Sometimes those letters can be a little bit confusing. And then the last one, obviously, computer that was purchased for $750. It sure does look like our starting point is at $750, so D goes with D. And you can say this pretty much the same explanation for each of these. This loan starts at $200, and so does our graph, and depreciates by $20 per week. I would add that there maybe. This one receives $30 per day, which means they start at $30. Our graph starts at $30. So the salary starts at $30 and goes up by 0.565 per mile. And as long as it says something about the starting point and how much it goes up by, that's pretty much good. I'll leave D for you to do on your own. All right, and last up here, how can you use a linear function to model and analyze real-life situations? Go ahead and take a minute to think about that. Maybe pause the video if you need a little bit more time. And then once you've got your answer, come back and see if it matches what the math teachers think. So, my answer for this would be that a linear function can model a value that increases or decreases at a steady rate. That's the whole idea of straight line depreciation. So a linear function, and however you word this is fine as long as you get the general idea. A linear function communicates a steady, non-changing rate. And I'm going to say that I don't have to say anything about appreciation or depreciation as long as it is the steady rate. So use the internet or some other reference to find a real-life example of a straight line. I'm going to go ahead and leave that one to you. Obviously, you all know how to use the internet. But my example for this would be a depreciable cost of assets. So something that looks like value in terms of time equal to negative 3,200t plus 35,000. This may be a function for, I guess what could probably be a car at this price, a really expensive car. And then if I draw my little table to indicate my values, if I start out in 2015, each year it's going to depreciate by that $3,200. So I started out in 2015 with that value, and then each year, notice it's going to decrease. 31,800, 2017, it drops down to 28,600, and so on and so forth until we get to, I guess I could have put 2018 in there. This would be 25,400, and 2019 would be 22,200. And then of course just graphing it. I know you all know how to graph, so I'm going to go ahead and cut the video short here for the sake of time. But if you have any questions on this or an example that you find, don't hesitate to ask.